Now we will consider questions of finding probabilities based upon normal distribution. In this video, we have answers of question numbers 9, 10 and 11. The question number 9 is the distribution of monthly income of 3000 workers of a factory confirms normal law with mean 900 and standard deviation rupees 100. Find the percentage of workers having more than rupees 800 and number of workers less than rupees 600 income. See, in this question, we are given the average monthly income and standard deviation of 3000 workers of a company. We are given that this monthly income of 3000 workers of the company follow normal distribution, which means that if you classify this monthly income of these 3000 workers first in a frequency table and then after that drawing its histogram, then using the histogram midpoints, top midpoints, if you join with a smooth curve, that curve will be like a symmetric frequency curve, and that symmetric frequency curve corresponding equation is that of the normal distribution equation. That is the meaning of these 3000 workers monthly income follow normal distribution. If normal distribution is used to address this monthly income of 3000 workers based upon the equation of normal distribution, we have to determine two things. First, the percentage of workers having more than 800 rupees income, and also number of workers having less than rupees 600 income. So this is under the assumption that these workers monthly income follow normal distribution. So we represent this monthly income of the workers using the variable x. And since we are given this monthly income follow normal distribution, we have the notation x follows normal, mean 900 and variance 100 square. We are given standard deviation rupees 100. So in the notation we write n 900 100 square. Now the first question is to find the percentage of workers having more than rupees 800 income. So since this is the percentage, it's actually a probability. Now the probability can be obtained by expressing the required event in terms of the variable. That is proportion of percentage of workers having more than rupees 800. So the monthly income of workers is represented by x. Therefore, actually we need the probability of x greater than or equal to 800. That is the monthly income of a randomly chosen worker has income more than 800 rupees. So after getting this probability, we can express it in terms of percentage. So probability of x greater than or equal to 800 is what we require. Now the variable x is given as normally distributed. But to find this probability of this x greater than or equal to 800, we have to use standard normal distribution. Okay, we can have a look upon the properties of normal distribution and also the standard normal distribution. The standard normal distribution is a normal distribution, a situation of normal distribution when the mean of the normal distribution mu is 0 and the standard deviation or the variance sigma square or sigma is equal to 1. So it's actually a normal distribution with mean 0 and sigma 1. In the present context, our normal distribution has mean 900 and variance 100 square or standard deviation 100. That means the mean and variance are not 0 and 1 respectively. So now we are not in a position to refer the probabilities from tables of standard normal distribution. So we have to transform the present variable x to standard normal random variable. For that, we make use of a transformation tool z equals x minus mu by sigma. in normal distribution, we have found that this property, that is, if x follows n nor mu sigma, z follows z equal to, that is, if consider a random variable following normal distribution n mu sigma square, we can show that z equals x minus mu by sigma follows n0 1. So this is a property relating normal distribution and standard normal distribution. Or using this transformation, we can transform a normal variable to standard normal random variable. Therefore, the limits corresponding to this normal distribution can be transformed to the limits corresponding to that of standard normal distribution. So in the present question, we are transforming this normal distribution limits, that is x greater than or equal to 800, to the limits of standard normal distribution. So x greater than or equal to 800 is equal to x minus 900 by 100 greater than or equal to 800 minus 900 by 100. That is, this probability of x greater than or equal to 100, 800 is equal to probability of this x minus 900 by 100 greater than or equal to 800 minus 900 by 100. Or in this step, we are finding the equivalent limits of standard normal random variable, that is the equivalent limit of 800. This x is now z, because x minus mu by sigma is z. So this is the variable. So corresponding to the variable x minus 900 by 100 is of z. Now corresponding to 800, we have minus 1. That is, x greater than or equal to 800 is equivalent to z greater than or equal to minus 1. This is how we transform a normal random variable to standard normal random variable, and the transformation is essential to refer the probabilities from tables of standard normal distribution, because in normal distribution we are given the mean is not 0 or standard deviation is not 1. The tables are prepared based upon standard normal distribution where the mean is 0 and variance is 1. So to refer the tables of standard normal distribution, we have to transform the given normal random variable to standard normal random variable. For that, we use this transformation device, where this transformation device is z equals x minus b by sigma. So using this transformation principle, we have to find out the equivalent limits of standard normal random variable corresponding to the limits of the given random variable x. So we have the area now probability of z greater than or equal to minus 1. Now this area corresponding to this z greater than or equal to minus 1 gives the probability of z greater than or equal to minus 1. And that area can be obtained from tables of standard normal distribution. So this is the tables of standard normal distribution. We need probability of z greater than or equal to minus 1. And you can read this in reverse order. That is, this is an open-end interval. That is, z greater than or equal to minus 1 means we have only one limit. That is minus 1, which is the lower limit. So if you write in the reverse order, minus 1 less than or equal to z less than infinity. So if any limit is missing, that missing limit can be taken as the default limit of the random variable. That is, z greater than or equal to minus 1 means the least value of z has to be minus 1. So the greatest value is the usual greatest value of the standard non-random variable, which is infinity. That's why we write the limit of this required probability in reverse order as z between minus 1 and infinity. Now, can represent the area required in a frequency curve of standard normal distribution in this diagram. So that is, this is the least value and here the greatest value. This is the point of minus 1, which is in the left side of 0, and we need the total area starting from the point minus 1 to infinity. That is, from this minus 1 to infinity, the total area occupied under the standard normal curve. So this is what we require. This area represents the probability of z greater than or equal to minus 1, or equivalently probability of x greater than or equal to 800. So how to refer this probability of z greater than or equal to minus 1 or z between minus 1 and infinity? First of all, note that in terms of standard normal distribution, the probabilities recorded in the table are corresponding to intervals starting with limit 0. That is, we can refer probability of 0 less than or equal to z less than or equal to 1.25. For example, that is always the lower limit must be 0. That is 0 starting intervals. But in the present case, the starting point is minus 1 to infinity. So we break this total interval minus 1 to infinity at 0. That is, one segment will be minus 1 to 0. The second segment will be 0 to infinity. Now, minus 1 to 0 means is a strip in the negative left side of the frequency curve. And in tables, we don't have tabulated values for the left side probabilities. But we have a beautiful property of normal distribution. The frequency curve of normal distribution is symmetric. Since the curve is symmetric, any area or probability required from the left side can be obtained by considering an equivalent sector in the right side. That is, here we consider an equivalent sector of minus 1 to 0 in the right side. Okay, that is minus 1 to 0 has an equivalent sector 0 to 1 because minus 1 and plus 1 are equidistant from 0, or minus 1 plus 1 is the image of minus 1 in the right side. So minus 1 to 0 probability will be same as 0 to 1 probability. So that is minus 1, 0 less than or equal to z less than or equal to 1. Now the second half part is 0 less than or equal to z less than infinity. Note that this 0 to infinity represents the entire right side of this standard normal distribution frequency curve, and its area is 0.5 because the total area is 1, and this line 0 divides them into two equal parts. Since the frequency curve is symmetric, so it is 0.5. So we had referred this area from 0 to 1 from tables of standard normal distribution. That is, the starting point is 0 now and the closing point is at 1. So corresponding to 1.00, that is by sorting this row 1.0 and the column 0.00, we have the value 1.00 as the value of z. So area from 0 to 1.00 is 0.3413, which is the coincidence of the row 1.0 and the column 0.00. Values of z are obtained by combining their row and column in corresponding order. That is 0.3413 is the area from 0 to 1.00. So we have 0.3413 is the area of the strip 0 to 1, or equivalently minus 1 to 0, and 0.5 is the area of the entire item. So the total area is 0.8413. So the percentage of workers with salary more than 800 will be 84.13. That is the answer of part 1. Now, the next is the number of workers having income less than rupees 600. So this is actually to find the number of workers out of 3000 workers having income less than 600 rupees. But before finding this number of workers out of 600, out of 3000 workers, we have to find out the probability of a particular worker family will be, worker income will be less than 600 rupees. That is probability of x less than or equal to 600. After finding this probability, if you multiply it with the total number of workers, we can get the number of workers having income less than rupees 600. So first our aim is to find out probability of x less than or equal to 600. Again, we have to transform the present x, which has not standard normal distribution, which has normal distribution with the mean 900 and standard deviation 100, to standard normal distribution using the transformation. Again, z equals x minus b by sigma. That is, in every computation of probability based upon normal distribution, first of all, we have transformed the given variable to standard normal if the variable given is not in the standard normal format. Using this transformation, z equal to x minus mu by sigma. because the table is prepared for standard normal distribution. The normal we are given are not with mean 0 and standard deviation 1. That's so the need of the transforming normal to standard normal is because of that. So in this present case, x less than or equal to 600, p of x minus 900 divided by 100 less than or equal to 600 minus 900 by 100. That is probability of set less than or equal to minus 3. Now we can express this again with the complete limits. This is an open interval because it has only the upper limit minus 3. The lower limit is missing. So the lower limit has been taken as the default limit of standard normal random variable, which is minus infinity. So we have both limits of set in the next line, that is p of minus infinity less than z less than or equal to minus 3. So area corresponding to this minus infinity to minus 3 has been given in this figure, that is the shaded area sector. Now to find this probability of this sector from standard normal distribution, we consider an equivalent sector in the opposite side because the table is given for positive values of set, that is set starting from 0 or starting from 0, that is 3 to infinity. The equivalent sector will be 3 to infinity. Now again you see that in tables we have given probabilities of 0 starting interval. Again, so we have to do here one more change, that is to get the probability of the other side 3 to infinity. From this point to infinity, 3 to infinity, we consider the entire right side 0 to infinity. From the entire right side 0 to infinity, we subtract the area from 0 to 3. The area from 0 to 3 can be obtained from tables of standard normal distribution. So if you subtract the total, if you subtract the area from 0 to infinity, the area from 0 to 3, the remaining area will be the area of 3 to infinity. So that's why the area from 0 to infinity, that is the entire right half, and from that area of the right half, we subtract area from 0 to 3, which we can obtain from tables of standard normal distribution. So in tables of standard normal distribution, you can see the area corresponding to 3.00, that is set greater than or equal to 3. So 3.00, that is 0.4987. So it is 0.5 minus 0.4987, which is 0.0013. So the number of workers with income less than 600 will be 3000 into 0.0013, which is 3.9, and approximately taken as 4. So that's about the number of workers having income less than 600 rupees. Now, in the next question, we are given a normal variate with mean 64 and variance 12 square. Find the probability of 4 intervals, x greater than or equal to 67, x between 60 and 67, x between 67 and 76, and x less than 60. So first of all, we are writing the given normal random variable in terms of its equation, its notation. X follows a 64 12 square. Here mu is 64 and sigma is 12. Now, we have the result of transforming normal to standard normal, that is that equals x minus mu by sigma follows n01 when x has normal distribution. That is, here x has normal distribution means not standard normal. That is mean with normal with the mean 64 and variance 12 square. Now first one is x greater than or equal to 67. So here also first of all we have transformed the x to standard normal, or we have determined the equivalent value of 67 for standard normal. For that we transform using the transformation principle, that is x minus 64 by 12 greater than or equal to 67 minus 64 divided by 12, that is set greater than or equal to 0.25, that is 67 minus 64 is 3. 3 by 12, that is 0.25. So we need the right tail area, that is set greater than or equal to 0.25 will appear in the right tail, but in tables we have only probabilities starting with 0 starting with lower limit 0. So we consider the entire right half. From the entire right-half, we subtract area from 0 to 0.25 because the rest will represent the probability of 0.25 to infinity. So 0 to infinity, from that we subtract area from 0 to 0.25. Area from 0 to 0.25 we can obtain from tables, that is the row 0.2 and the column 0.05. That's the coincidence of the row 0.2 and the column 0.05, which is 0.25, and corresponding to that it is 0.987. So it is 0.987, and this is the entire right half. Its area is 0.5, so it is 0.4013. Now the next is 60 to 67. Again the same step, transforming to standard normal. So 60 minus 64 by 12, 67 minus 64 by 12, and the middle is the variable, that is z. So these are the limits. Again it laps to both the left and right side, minus 0.33 to 0.25. So we have a break at 0, that is minus 0.33 to 0, and 0 to 0.25. And minus 0.33 to 0 is similar to 0 to 0.33 because of the symmetric property, and we shift to the right side to refer the area from tables of standard normal distribution. So the area from 0 to 0.33 is 0 to 0.33, that is, this is the area 0.1293, that you can see here 0.1293, and other is 0.25, which is as before 0.0987, 0.25, 0.0987. So total is 0.228. The third is between 67 and 76. So here also we are finding the equivalent limits of standard normal random variable. That's they are obtained by transforming normal to standard normal, and it is 0.25 and 1. And this 0.25 and 1, that sector lies entirely in the right side. That is, this is the 0.25, and here it is 1 in between the strip. That is the area required here. So to find this area, we first consider the total 0 to 1, that is starting from 0 to 1, and next we consider 0 to 0.25. So then if we subtract the area 0 to 0.25 area from 0 to 1, the remaining will be the area of the strip between 0.25 and 1. So 0 to 1 area is again 1.00, 0.3413, and 0.25 area is 0.0987. Therefore, this is 0.3413 minus 0.0987, which is 0.2426. Now we have another range x less than 60. Again standardizing, z less than or equal to minus 0.33. That is, the area is in the left tail of standard normal distribution. So we consider an equivalent sector in the other side, z greater than or equal to 0.33. And this equivalent sector area can be obtained by considering the entire right side and also subtracting the area from 0 to 0.33. So the entire right side area is 0.5. Area from 0 to 0.33, we can from the tables 0.1293. We can get from tables 0.1293. So when we subtract, it is 0.3707. So we consider different intervals of x, and all these probabilities are obtained by transforming the variable x to standard normal, and that transformation we make use of the property x follows n mu sigma square, z equals x minus mu by sigma follows n 0. Now the next is the number x is normally distributed with mean 15 and variance 16. Find p of 12 less than x less than 60. Okay, so here again we are finding the equivalent limits of standard normal, and that is obtained by subtracting mean and dividing standard deviation from all the entries. So this is 12 to 20 is now minus 0.75 to 1.25. So we break at 0 because the total range will lap from to the left and right side. So minus 0.25 to 0, the first part. Second part is 0 to 1.25. And we consider, now we get areas of the each part from tables. One is 0 to 0.75, So 0.75 is 0.2734. And the other is 0.2734. Other is 1.25. So 1.25 is 0.3944. So it is 0.3944. So the total area will be 0.6678, which means that probability of x between 12 and 20 will be 0.6678. That's the answer of question number 12.